Semiconductor Packaging. John D. Thomas, Alex Ruth. Book 4, Section 1, Chapter 3, Topic 4. Understanding Brittle and Ductile Materials in Semiconductor Packaging.
Introduction. In semiconductor packaging, materials play a crucial role in determining the structural integrity, reliability, and performance of packaged devices. Two common classifications of materials based on their mechanical behavior are brittle and ductile. Understanding the differences between brittle and ductile materials is essential for selecting suitable materials, designing robust packages, and preventing premature failures.
This overview delves into the classification, properties, behavior, and applications of brittle and ductile materials in the context of semiconductor packaging.
Classification of brittle and ductile materials. A. Brittle materials. Brittle materials are characterized by low toughness, limited plastic deformation, and sudden fracture without significant prior deformation. Brittle materials tend to fail catastrophically when subjected to stress, exhibiting little or no warning before fracture. Examples of brittle materials include ceramics, glass, certain polymers, and some metals at low temperatures. B. Ductile materials. Ductile materials are characterized by high toughness, extensive plastic deformation, and gradual failure through yielding and necking before fracture. Ductile materials can undergo significant deformation before ultimate failure, providing warning signs such as necking, yielding, and deformation. Examples of ductile materials include metals such as aluminum, copper, steel, and certain polymers. Properties and behavior. A.
Brittle materials. Low ductility. Brittle materials have limited ductility and exhibit little or no plastic deformation before fracture.
They tend to fail abruptly without warning when subjected to stress beyond their ultimate strength. High stiffness. Brittle materials are often stiff and rigid, with high Young's modulus and low compliance. They resist deformation and tend to maintain their shape under external loading.
Low toughness. Brittle materials have low toughness and poor resistance to crack propagation.
They fracture easily under stress, with little energy absorption and minimal deformation. Brittle fracture. Brittle fracture is characterized by smooth, flat fracture surfaces with little or no plastic deformation.
Crack propagation occurs rapidly, often along crystal boundaries or grain boundaries, resulting in cleavage or intergranular fracture.
B.
Ductile materials.
High ductility. Ductile materials exhibit significant plastic deformation before fracture, undergoing elongation, necking, and yielding under tensile stress. They can withstand large strains and deformations without catastrophic failure.
Moderate stiffness. Ductile materials have moderate stiffness and elasticity, allowing for substantial deformation and yielding before fracture. They exhibit higher compliance and lower Young's modulus compared to brittle materials. High toughness. Ductile materials have high toughness and energy absorption capacity, enabling them to absorb energy and deform plastically before fracture. They exhibit resistance to crack propagation and exhibit rough, jagged fracture surfaces. Necking and yielding.
Ductile materials undergo necking and yielding before fracture, with localized deformation and strain concentration leading to the formation of a necked region before final failure. Thanks for watching.
Please like, share, and subscribe.